Good morning, everyone. Coming to you from sunny Albuquerque today. We are going to talk about xHaul strategies. That's the title of the talk. It's going to be a primer on where we are, I guess, as an industry in terms of backhaul and where the RAN is going. We've been hearing about 5G for a long time in the rural spaces. Haven't seen much in terms of deployment, really almost by definition. I think we're going to see 5G rolled out in the urban areas first, but let's go ahead and get started, and we'll talk through this. So first, we're going to talk about why is this changing at all? Why is there a change in architecture? Why do we have to adjust how we are moving data from cell towers back to the backbone and to the switching centers? That architecture is changing, and so we're going to look at the reasons behind that. Then we're going to talk about what is xHaul, right? This is a term that's thrown around a lot. A lot of you may already know what that term means, but my strategy here, or the way I like to do things, is to start from the ground up and just start with definition of terms and acronyms. Then we're going to talk about the different RAN types that are out there today and where we're going. Then we're going to talk about Ribbon's Neptune product. It is uniquely suited to support the various xHaul strategies out there today and fits in every RAN architecture that is currently available. And we'll talk about some deployment models as well. All right, so what's the big deal, right? Why is there so much talk about RAN architecture, backhaul, xHaul, front haul, mid haul, all of these different hauling strategies? Well, the simple matter of the fact is that LTE, which is generally where we are today, or 4G, moving to 5G is not simply a capacity increase, although it is that. It's certainly a large capacity increase. But in order to manifest everything that 5G is designed to provide, increased bandwidth, greater connectivity, in many areas with little microcells, you're going to be able to eliminate dark spots, right, or holes in the network. You'll be able to light up arenas with either private or public 5G wireless. It is massive throughput. It is massive connectivity, and then there are a number of additional value adds that 5G is designed to provide in terms of machine communication, hard slicing, soft slicing, to provide a much higher degree of resilience and quality control over that signal. So 5G is really a quantum leap. It is not the same as 3G to 4G. 4G to 5G is like coal power to nuclear power, right? Skipping several steps in between. So if you look at this quick chart here, you'll see that on the top we've got LTE and generally what size the interfaces are at each part of the network, from the haul, from the cell towers, from the cells, across the access, and then to the aggregation and up to the core. You'll see where those interfaces go from 2.5 gig to 1 gig, typical interfaces 10 gig, and then 100 gig backbones. Down at 5G, you'll see that there is roughly a 10 times multiplier, right? So we go from 2.5 gig interfaces out by the cell tower to 10 gig or 25 gig interfaces, and massive amounts of throughput as compared to today. So you are basically seeing a 10 times multiplier across the board on every interface every device participating in the cellular network. Not only that, but you're going to end up in many cases with 10 times the remote radio heads, right? 10 times the antennas. And a lot of cases, those are going to be little mini cells or micro cells. So, obviously you won't have 300-foot cell towers everywhere, but there will be ubiquitous smaller 5G towers in order to provide that capability. So let's talk about xHaul, right? X just means it's a variable, right? So we can talk about backhaul, which is what we've had for, well, from the beginnings of RAN, to front haul and mid haul. Haul simply means IP and/or optical transport for your wireless traffic. That's all it means, right? Which type, whether it's backhaul, front haul, or mid haul, depends on where it is in the network and what purpose it's serving, right? And as you'll see here in a moment, you can actually have front haul, mid haul, and backhaul all in the same network because they perform different tasks. So backhaul is what we've had traditionally. This is where you are going from the tower to your MSC, to your core network, your mobile switching center. It is typically Ethernet traffic. It is, by today's standards, it's usually pretty small in terms of bandwidth or throughput because it didn't need to be big. We were only carrying 3G and then eventually 4G traffic. These are what are called distributed RAN or DRAN architectures. You really only have two places in the network where you have equipment. One is at the cell tower, or at the top of the cell tower, and then at the hut at the bottom of the cell tower. And then you'll have the backhaul circuit or service to your switching center, right? And that's where your equipment is. Well, so as we move towards 4G and then 5G, it becomes more important and more cost effective to start to spread out the equipment, right? So instead of having an antenna and then a baseband unit to process the signal and put it on fiber at the bottom of a tower, now we can put remote radio heads out on towers or mini cells and then send many of those to a central baseband unit and have one BBU handle the traffic for multiple towers. Well, now I have one device. I can centralize that device. I can serve multiple cells, and this by definition is more cost effective, also much easier to administer for the human beings that have to administer the network. So moving down to front haul, we are moving from the tower, information from the tower, up to the BBU over these green lines, which are titled front haul. So that's the front haul piece. Note that from the BBU to the core, we are still backhauling. Okay, so in this case here, we've got front haul and then we've got backhaul. Now, moving down to mid haul, this is really specific to 5G RAN solutions. This is where we take the BBU and we split it into two separate devices, again, to give us the leverage, if you will, of serving one to many, right? One device to many subtending devices. Again, one more level of the capability to administer one device and serve many locations over a hierarchical network. So once we've split that BBU into a DU and a CU, then the connection between those two devices becomes mid-haul, right? Now, all of this is necessary because of the slide I just showed you. The move to 5G necessitates that we do this in a cost-effective manner. And so everyone is looking for efficiencies in the architecture to make sure that that we can serve 5G, provide 5G at a rate that people can afford, right? That's really the bottom line here, right? So that's what's driving, in the main, that's what's driving these architecture changes, okay? Ultimately, all of these are data transport, right? Depending on where they are in the network, of course, they have different names, and there are different handling characteristics, but ultimately you're moving data from one location to another. This is Ribbon's stock and trade, and so all of these solutions are available in our portfolio. So let's take a look at RAN. And why we're moving. This is the other side of it, right? So RAN is radio access network. We've talked about the backhaul piece. The backhaul piece is really driven by the architecture of the RAN. So traditionally what we've had is DRAN, distributed RAN. This is where, as I mentioned before, your equipment is either at the cell tower, well, it's at the cell tower, and it's also at your mobile switching center and on the backbone, the core, right? In between, you just backhaul from one to the other, okay? So like in my last slide, where we start moving some of that equipment to a centralized location and building that hierarchical topology where I can use one base unit to manage several cells, and then I can use a combination of DUs and CUs to manage multiple baseband units. Excuse me, multiple towers as well, splitting the baseband unit into CU and DU. That is all part of the RAN architecture, and so if you look here at the top of the slide, you'll see distributed RAN, which is what we've been using for years, right? It's traditional 3G, 4G architecture. All of your remote radio units, the antennas, and the baseband functions reside at the tower, and then they're backhauled to a hub site, okay? We have been moving to a centralized RAN during the 4G LTE days, and this moves, as I've mentioned before, the BBU to the hub, which allows that single BBU to support multiple antennas or cell sites. And then we are moving to virtualized RAN, vRAN. And so this is not necessarily an architecture change in terms of how we're moving data. What this allows us to do is, instead of creating purpose-built baseband units, CUs, DUs, and so forth, what we can do is virtualize those using network function virtualization, or NFV, and then run them on merchant silicon or off-the-shelf hardware. Again, this keeps the cost lower, right? Allows us to run those functions in software on much cheaper hardware. Well, this does a couple of things. One, it obviously drives the cost down, but two, now you're not dependent upon a single vendor to provide that solution for you. So it breaks the vendor lock cycle where you're stuck with one vendor. It allows multiple vendors to compete for your business, allowing the best of the breed virtualized solutions to run on the hardware that you've chosen to put in place. And then the ultimate realization of this is to continue the vRAN, the virtualization capabilities, but then to move what's being called ORAN, or Open Radio Access Network. This is where you have multiple vendors out there, true best of breed, where I can use vendor X for one location and vendor Y for one location, vendor A, vendor B, and the open standards and the virtualization allows you, the service provider, really ultimate choice in how you're going to support your network. The architecture is essentially CRAN, but the virtualization and the open standards are where Ribbon sees this going, and I think it's better for the industry. It's certainly better for service providers, giving you a lot more choice as you move into that 5G world. So, as always, right, we're not going to forklift the entire RAN environment in North America. And so one day it's 3G in some places. I actually got 3G on my phone the other day in far West Texas. I hadn't seen 3G on my cell phone for a long time. But there's 3G, there's 4G LTE, and then in some cases there's 5G. We're not going to forklift all of that and go to this bright, shining future overnight. So you're always going to have a mixed environment. And so what are the challenges that we are going to run into as this migration continues to occur? Well, on the business side, of course, you're always looking for your fiber to maximize the fiber that you've got in the ground. And where you have a lack of fiber, you're always faced with the choice, do I lay more fiber? Expensive. And in these days, difficult to find the fiber in some cases, right? Or do I put a solution in like DWDM, right, where I can put multiple wavelengths on my existing fiber and maximize my use of that in-ground asset. Always being pushed for higher capacity. That is something that we're going to see through the rest of our careers and beyond. You know, there's just no end in sight for for bandwidth usage. But at the same time, we've got to drive that cost down, right? You can't simply look at what you have today, multiply it by 10 or 100, and then multiply the cost by 10 or 100, and then expect to sell that, right? So while we are moving to much greater capacity, we have to drive the cost down on a cost per bit basis so that it's a sellable product. There are increasing advanced service demands. So you're going to be looking at, even over the RAN, particularly with 5G, you're going to be looking at people that are looking for very low latency. They're going to run applications that are very latency intolerant. They're going to want instant access. They're going to want to run multiple apps at one time. All of these are requiring new protocols, new optimized ways of moving traffic and traffic engineering that we just didn't need with LTE, 4G, and before, right? So these demands are going to push us forward. And then in many cases, you're going to have multiple tenants, each of which is going to demand a different SLA depending on what their business model is. They may require, say, a platinum level service, and then others may take gold, and then others may just look at more of a best effort service. This is an opportunity for you as a service provider, because obviously if you've got an SLA and someone demands a platinum level service, number one, you need to be able to support that service, but number two, you get to charge a premium, right? So this is one way to maximize revenue from a small footprint that maybe the footprint's not growing, but with the advent of 5G and the capabilities to meet these advanced demands, it'll give you new revenue opportunities there. I've talked a little bit about this, technical challenges, but this is a quantum leap forward in terms of how we're going to be handling RAN traffic. One issue that I've already identified is that we're not going to migrate overnight. We're going to have, in many cases, we'll have one or two or even three different types of RAN that are out there, and your equipment's going to have to handle all of those, right? Without saddling your radio guy or your 2 or 3 people that are responsible for that network with having to know a dozen different systems, right? That's just, it's not workable, right? It's a non-starter. There are differences between the macro towers, right? And then these little micro cells that I've talked about, right? Like lighting up an arena or a downtown area with 5G. Those are challenges that have to be overcome. Convergence of 4G and 5G. 4G is likely going to stay for some time. And in fact, in many cases, 4G will simply be one of the data slices that runs across your 5G stream, right, for 4G customers. So that is something that has to be managed as well. RAN vendor interoperability. At the moment, we're working towards virtualization and open RAN, but until we get there, your RAN vendors are going to have to work and play well with each other, right? This is a core philosophy here at Ribbon, is that we expect to have to work and play well with others. We are not expecting you to build an all Ribbon network end to end, nor should you have to. That's vendor lock. That's not good for anybody. It's not good for innovation. It's not good for the end provider. And so that's something that we definitely want to steer against. And then finally, one big challenge that is being addressed is timing distribution. So it's absolutely critical when you are providing those advanced services and the latency and delay intolerant services, that the network is synced appropriately so that you don't get log jams, backups, congestion, and so forth, and then out of sync data delivery. Imagine an autonomous vehicle that has some onboard intelligence, but then is counting on a 5G network to communicate with it, to give it traffic conditions and so forth, right? Well, that's a situation where you have a vehicle moving in real time. It cannot be delayed. Timing sync is absolutely paramount there. And so the timing accuracy for 5G is an order of magnitude or more important than it was in 5G. And so there are special timing considerations there. All of these are supported and are being worked on here at Ribbon. We're the first vendor out with a 5G ready platform in our Neptune devices, and you'll see some of those technologies there on the right, being able to provide multiple 400 gigs, modular and flexible chassis operations, so that you can fit our solution in multiple locations depending on what their service demands are. Being able to do hard slicing and soft slicing. So for those of you that don't know, slicing is sort of QoS on steroids. Slicing literally will identify a software path and a hardware path through the solution that cannot be used by any other service. So if I have an ultra premium customer, then I can not only use my software to isolate their traffic and give them effectively an HOV lane through the network, but I can register and reserve hardware components, interfaces, portions of CPU, portions of RAM that can only be used for that customer. That's hard slicing. These are technologies that have come about because 5G is driving us there. So really what is necessary here is a comprehensive solution that will cover all of the different xHaul solutions that are out there today, right? From backhaul, which is traditional, front haul, which we've seen for a while, and then mid haul as we move into the CU-DU baseband unit split towards that CRAN architecture. But we're going to see a mixture of these things over time. And so what is needed is a hardware software solution that not only supports the hardware requirements that we've been talking about in terms of slicing, in terms of optical capabilities for WDM to maximize your fiber in terms of front haul, and then provide that IP MPLS solution for soft slicing all the way through the network. And then on top of that, because it is getting more complex, necessarily so because of what 5G is demanding that we support. You need a software solution, right? And this is more than just an NMS. This needs to be an orchestrator, right? an orchestrator that will manage all of this hardware, that will be the interface from your human beings to your RAN network, that implement what the humans need to do to support customers, but then abstract these hardware pieces and what actually needs to happen from box to box to box. It also needs to manage an older DRAN solution, which I say it's old, but it's still out there today and is likely to be out there for some time. It needs to support CRAN. It needs to support the open RAN solutions and network function virtualization, or vRAN. The benefits are obvious to moving towards that, particularly for service providers and rural operators. So your solution really needs to keep that in mind and be able to support all of that. And then finally, on top of all of this, it needs to maintain the quality, right? So it needs to monitor your key performance indicators, right? Or your KPIs, those SLAs that you put in place. It needs to monitor everything from OTDR on the fiber to your signal strength. If you've got DWDM out there, then it needs to support non-linearity detection and signal to noise ratio and so forth. All of these metrics are really more than a human being can manage. That's why you need a tool that takes care of all of this in a single pane of glass that gives you at a glance the metrics that you're looking for, will identify potential problem areas where you may need to do some preventive maintenance, and then makes it easy to set up those service categories so you can provide bronze, silver, gold, and platinum type services for increased revenue opportunities. So that's what we're talking about here. This is what we at Ribbon called unified xHaul, and the orchestrator is a product that we call Muse. You're seeing a little picture of it here. Muse in and of itself would warrant a tech talk, so we're not going to dive deep into it, but this is the tool that is required to manage not only the existing networks that we have out there, but to manage and orchestrate as you move into the CRAN, vRAN, and ORAN. It is designed to support all of these, depending on where they are in your network, in a unified fashion. So Ribbon, for those of you that may have been party to my earlier Tech Talk series, this diagram will look familiar to you. For those of you, this is the first time you've seen it. This is what I call my Frisbee diagram, or a layer cake. What it is designed to express to you is Ribbon's holistic approach of looking at your network in terms of which tools need to be brought to bear, right? So at the bottom, using the OSI model as kind of as our guide, at the bottom we typically put the optical layer, our product called Apollo. The optical layer is that WDM piece. Doesn't necessarily have to be WDM, but that's usually a big part of it. It's anywhere you need massive scalability in the terabit range, 400 gig throughput over long distances where we may need to amplify. Out here in the West, it's a long way from one CO to another. And so being able to move that data a long distance is obvious, and in a cost-effective way is obviously paramount. Neptune is the next layer up. Neptune is where the magic happens, right? So this is layer 2, layer 3, a solution that we call the multi-service transport platform. It has been purpose-built to support layer 2 operation at, say, MPLS-TP, EVPN, standpoint, and then also layer 3 operation, BGP, IS, OSPF, full featured internet routing, all the way from the aggregation to the core. And then on top is the Muse orchestration. Muse is a product that is more accurately defined as an environment. So in some cases, if you just need an NMS, then Muse can support just the NMS piece, right? It is a container-based open standards software solution where we can place whatever containers, whatever solutions that are necessary for your environment into it, and then nothing that you don't need. So it's really ultimately customizable. This is the framework in which we fit our orchestration and then our xHaul solution to support the various RAN architectures out there. Any of these tools can be added. If you don't need them, then they can be removed. Again, giving you just what you need in a cost-effective manner. So to wrap up, I've been going for about 35 minutes here, and that's usually what I like to spend for presentations like this, to give you just a flavor of where we're going with this, where the industry's going, and where Ribbon stands on it. Ribbon is for those of you that aren't familiar with us, we are a standards-based IP and optical solution company. Our IP and optical product line and heritage goes back to 1961 and is globally deployed in over 140 countries, including many governmental organizations, critical infrastructure, power plants, defense agencies, and so forth. So it is built to a very high standard of quality and expectation. Our licensing model is one that we've taken from being in the industry ourselves for years and seeing what works best for customers. We don't charge persistent licensing fees. So once you have chosen your solution and purchased the licenses for your equipment, then you never get another invoice from us, right? You own that solution, and we'll be there to support you in the future. From a support standpoint, our support is 100% based right here in the United States. It is based in Fort Lauderdale, Florida, where we have a top-notch lab where we do interoperability testing. We stage all equipment that comes in from the factory and burn it in, do pre-configurations, palletize it, and ship it to your location, having given it a once-over before you even get to see it. For those of you that are considering in the rural spaces, some of the government funding that is coming down the pike, and why wouldn't you? It's a remarkable opportunity, once in a career, I've heard it described as, opportunity to get these networks built to serve the rural communities and finally bridge that digital divide we've been talking about for 20 years. Our equipment is Buy America Act compliant. So what that means is often when you're getting money from the USDA through RUS or other programs that are out there, they will have a requirement that that equipment needs to meet Buy America Act standards. So this doesn't necessarily mean the equipment is manufactured within the contiguous United States. What it means is it can be made here in the US or in about a dozen countries that we consider compliant with that act. So these are countries like the United Kingdom, Canada, Australia, Israel, and so forth, right? So that is where Buy America Act comes from, and so you can do business with us in confidence that the USDA will give you a check mark of compliance there. And then finally, we are delivering everything in our portfolio within 10 to 12 weeks. This is unusual today. I usually don't have a conversation in my travels speaking to many of you where the words supply chain don't come up. because COVID and the resulting shutdowns and so forth really obviously threw us all for a loop planet-wide. Through a series of good planning and then simply having moved to shorten our supply chain before COVID even hit, we are still in a very favorable position to deliver virtually everything that we've got on the truck, so to speak, within a 10 to 12 week time frame. So if you're looking at the calendar, if you're looking at the clock, and time is ticking down to get that solution implemented, give us a call. We have been able to help many customers that whose normal vendors just simply couldn't meet their timelines. And so we're happy to talk to you about that. And with that, I appreciate your time. There's my contact information. Thanks for hanging out with me this morning. If I can answer any questions for you, feel free to type them in. I've got Glenn here standing by to help. You can also feel free to contact me via email. That's my cell phone number. And look forward to speaking with you. Thanks. Back to you, Lance.
Thanks, Jack. We did have a couple questions. I think you covered a lot of the materials in the questions, but since we had the questions, I figured maybe it's worth repeating.
Sure.
So how can we best serve the networking challenges of anticipated site cell densification with small cell growth? Pretty sure you covered that, but again, maybe worth repeating.
Yeah, so one more time, I think you broke up there a little bit for me.
Oh, sorry. How can we best serve the networking challenges of anticipated cell site densification with small cell growth?
Yeah. So, Glenn, I'm going to ask you to answer that one because I think that's right up your alley.
So, yeah, it's a good question because one of the major challenges with new frequency spectrum to serve higher capacity services, as well as ultra reliable, the time sensitive, challenges of many of the sort of prospects of 5G are going to suffer from higher frequency spectrum that's good for capacity but bad for coverage. And so the coverage model of higher frequency spectrum is so much smaller, therefore cell site densification has to occur. And the quickest way to market and really the most cost-effective way to serve URLLC and even enhanced mobile broadband services of 5G, the prospects of 5G, is with small cell. But the challenges with small cell, these are radio components that are installed on light towers, sides of buildings, in urban areas, even in rural areas, because it's quick to market to stand up a small cell, and it's often based on events that happen within a town or where there's a congregation of subscribers, whether permanent or temporary basis. And so small cell is really going to see massive growth. The challenge, how do we provide an effective networking solution for it? So one is it requires a lot of fiber. So the connectivity solutions really have to handle the scarce resources of fiber. Number two, there's not really the environment to stand up networking equipment at a small cell location. And so we have a solution set that's been widely adopted by the prevailing mobile operators here in North America, and that is leveraging two key components for this. One is a auto-tunable SFP that provides the WDM functionality for multiplexing multiple signals from a small cell location over a passive MUX that can be installed in a pole or under the cell site location, or some place that, where there's low power and low footprint. And so these are passive devices and the auto-tunable optics work with all radio suppliers. So over the years, we've advanced and modified and revised the EEPROM functionality within these auto-tunable optics to ensure that the radio components interoperate with the hub site components, like you mentioned, the BDU and the DUCU, with the RU out at the cell site location. And so this is a very elegant, very important technology that we offer to the marketplace that's been adopted by really all the mobile operators here in North America to stand up small cell service quicker over fiber assets they have, leveraging WDM multiplexing wavelengths that can be auto-tuned on SFP optics that fit in any radio supplier's equipment. So a very elegant way to bring up small cell solutions, what we call semi-active solution set. Yep, so very good question.
Thanks, Glenn. Okay, and we just have two other ones here. Does your provisioning agent cover your xHaul solutions as well?
Does the provisioning agent cover the xHaul solutions? Yes, absolutely.
Okay.
Yeah, you bet.
Love those yes or no answers. Those are easy.
Yeah, there's no question about that.
And this last one, you definitely covered it there on your last slide about our supply chain and our sort of 10 to 12 week window of deliverability. But just again, the question might be worth repeating on how is Ribbon able to do that? What are the reasons why we're able to deliver on that 10 to 12 week?
I mentioned a couple of things along that. Honestly, it's good planning overall because shortening your supply chain is always a good idea. There are certain locations in the world where it has become somewhat problematic to get reliable components. To be sure, that the components were inexpensive, but there have been, I guess, geopolitical events and so forth that have challenged the stability of that part of the supply chain. And so, quite frankly, we started shortening that supply chain and moving things out of that part of the world as an oversight on how to do business, right? And as it happened, COVID occurred, about a year after we began that process. Which is honestly, I describe it as a bullet that we dodged without knowing. It just so happened. So it's a combination of good planning and just luck, right? That we ended up in a situation where we're not subject to those long delays in getting components and manufactured goods. So, yeah.
Okay. Yeah, fair enough. Glenn, I may have you look at that question that just came in. It may be better for you to read that and can respond, or perhaps Jack, but do you see that one there?
Yes, I see it. So how important are considerations for flexi capability and low latency design for rural providers that don't need to do a 5G backhaul today, but might in the future? Yeah, so, flexi is specifically to the question, flexi offers additional capabilities of slicing. So as Jack mentioned, whether an operator providing wholesale backhaul services, backhaul, front haul, mid-haul services on behalf of a mobile operator, or the mobile operator, or those rural operators that stand up their own RAN and provide their own assets and own services for xHaul. Flexi gives an additional capability in terms of implementing network slices. And as As Jack mentioned, a network slice is it's basically a virtual transport path along some segment of xHaul, front haul, mid haul, back haul. And so having that additional toolkit where the slice can happen in essence at the MAC layer, right? So FlexE creates channels within an Ethernet interface, and those channels can be dedicated to ultra reliable low latency service. As Jack mentioned, you want to really separate services that are in major categories into different slices, and one being your LLC, so time sensitive, services that you don't want being interfered with high capacity services, that can be implemented in an Ethernet channel with FlexE, because FlexE creates the shim and creates multiple channels within a single Ethernet interface. So it gives the operator added flexibility in implementing slices, in addition to what Jack referred to as soft slicing, which is implemented by creating, in essence, VPNs across your Ethernet IP MPLS infrastructure, and dedicating a class of service to each of the VPNs in a software, sort of a traffic classification model. So having IP MPLS in your network elements to implement soft slicing through segment routing and other MPLS conventions, as well as at the MAC layer with FlexE, gives a operator ultimate flexibility in how they could stand up network slicing to serve sort of the prospects of what 5G is going to become. Then there was also a question related to low latency design for the FlexE does have some aspects related to low latency. Over multiple hops, channels can be stitched together such that it's not a store and forward between multiple elements, in a backhaul. But the low latency design really is more, there's other aspects of that contribute to low latency designs, such as time sensitive networking in front haul, in proper QoS mechanisms and this is for the data plane, for forwarding subscriber traffic, user plane, control plane traffic from this cell site back to its destination. But the other important thing that Jack mentioned, which is very important, is not just the user plane traffic and forwarding that to meet latency and jitter requirements, but also synchronizing the radio elements with the hub components. It's incredibly important with 5G for various reasons that Jack noted. And so the synchronization is also carried over your network in timing distribution, and having Class C timing accuracy, which is defined by various IEEE and bodies that define capabilities of timing synchronization using PTP. Ribbon's set of portfolio for xHaul all support Class C timing accuracy for the proper synchronization of radio elements with the with the hub site components. And so there's three aspects. There's timing synchronization, there's forwarding to meet latency and jitter requirements, and then there's what are the mechanisms I have to implement slicing, either if I'm a mobile operator, to ensure that I have different virtual networks for the different services that I'm offering, or if I'm a wholesale operator serving mobile operators, to ensure that my infrastructure will support the demands that the mobile operator will give me in terms of expecting certain kinds of slices in a network or VPN services to isolate and best serve each of my classes of service. I hope that answers it.
One thing I'll mention is, because Brian, you put the word future in there, right? So when we deploy a solution for you, we fully expect that solution will be in the network for 10 years, right? So when you are investing in a ribbon deployment, then you are expecting that, and we fully believe that you should expect that whatever solution you put in is going to support what comes down the pipe 5, 6, 7, 8 years from now, right? So we are ready today for that 5G backhaul solution. maybe you don't have it today. And I think that's probably the case in a lot of places, right? But will you have it in 5 years or 7 or 9, right? If so, then you're well positioned for it whenever it comes down the pipe, right? We don't believe that you should put a solution in and then 3 years later forklift it, put something else in, right? And our design philosophy and the way that our solution has been envisioned and conceived really supports that, right? That you'll be able to upgrade those locations over and over and over again throughout the life of that shelf. All right, Lance, do we have anything else? Doesn't look like it.
I think that's everything. Some good questions there, some good answers too, so appreciate that. Want to remind everyone we will be having replay links sent out so you can rewatch this, and if you have any questions that come up there, feel free to reach out to Jack. I believe Elizabeth put her information as well into the chat. And of course, ribbоncommunications.com, you can find all kinds of ways to get a hold of us there. Should you have any questions, there will be a copy of the slides too. So once you receive those and you have a question, just hit reply and let us know. We're here to help. Thanks again for attending today. We really do appreciate all your time, and just be on the lookout for the next webinar coming soon. Thanks, Jack.
Thanks, everyone.